Good day, everyone. This is our latest iteration of the Storm of the Month series. So this one is going to focus on the August 7th supercell that formed near Tribune. Here are the topics we're going to cover for this presentation. We're going to start off by looking at the Synoptic scale setup for the day. And then after that, we're going to look at several convective parameters that were in place during the day. And then really the heart of this presentation is going to be the radar analysis. We're going to look at some features that were present before the tennis ball hail was reported at Tribune. And then we'll conclude with some final comments. Starting off with the large scale setup, at 500 millibars, you can see we have a shortwave trough that is moving in from the west and is actually centered over our area by 0Z. Moving down to 700 millibars, you can see there's really not a lot of movement with this trough, as it remains pretty well centered over our area through the day. Going down to 850 millibars, similar story where there isn't a whole lot of movement with this trough either. And if you remember, from 850 up to 500 millibars, we have pretty much a vertically stacked trough by 0Z. Going down to the surface, at 12Z, we have a frontal boundary that's roughly bisecting the area that's running from north to south. And then by 21Z, the frontal boundary has actually shifted to the east a little bit, but is running roughly right over Tribune by 21Z. Looking at our convective parameters, the loops you're going to see in these slides that we're going to look at are going to be running from 18Z through 0Z. As you can see with this animation, the mixed layer sin actually erodes by about 2 p.m. as the sin is the image here. And the mixed layer cape has about 1 to 2,000 joules available when that mixed layer sin finally erodes. And you notice there's actually a narrow corridor that erodes first by 2 p.m. And that's actually right along the frontal boundary. So that's what allowed these storms to develop there near Tribune along that front, was that mixed layer sin eroding along the frontal boundary first. Looking at most unstable cape, similar story, about 1 to 2,000 joules of cape that were available. The image we have here is a lifted parcel level. And the lifted parcel level is the level in meters at which the air parcel is the most unstable. So a white background indicates that the surface level is the most unstable for a given parcel. The higher you go, the warmer the colors are. So you can see that behind the frontal boundary, over the western part of the area, the air was quite stable, as indicated by the warm colors there. And those were roughly 1 to 2,000 meters that the air parcels had to rise before they became unstable. Looking at the 7 to 500 millibar lapse rates, you can see that they were actually quite steep for the day, about 8 degrees C per kilometer. And we had some steeper lapse rates east of where the storm actually fired, interestingly enough. Effective shear was pretty strong for the day. It was around 40 knots when the storm first formed, and I think if you look at the animation closely, we might have even had some 50 knots of shear there toward the late afternoon. All right, now we're going to get into really the meat of the presentation with the radar analysis. So the loop here I have on the right is of the half degree, and it's of the storm of interest moving over Tribune and actually east of Greeley County. So the storm of interest first shows up on the half degree at 2:22 p.m. However, it initially shows up on radar 6 minutes earlier at 2:16 p.m., and that was at the 4-degree tilt. By 2:29 p.m., we have a storm top divergence of 132 knots, which increases to 140 knots by 2:37 p.m. So within 21 minutes of first showing up on the radar, the storm was already having 140 knots of storm top divergence. So just one clue there of many that this is an incredibly rapidly intensifying storm. We also had 50 dBz up to 40,000 feet above ground at 2:37 p.m. This did fall a little bit to 35,000 feet AGL at 2:42 p.m. Our tennis ball size hail report came in at 2:40 p.m. So 3 minutes before the hailstone was reported to us, we had a storm top divergence of 140 knots and 50 dBz up to anywhere between 35 and 40,000 feet AGL. So looking at several features here that would kind of serve as precursors for severe hail occurring with this storm, the most helpful I found were the beware being present, the storm top divergence, and the CCs. And we're going to be looking at those at several points in the storm's lifetime. So looking at the beware, this one first showed up at 2:34, so 6 minutes prior to the tennis ball size hail falling in Tribune, the beware first showed up. And this lasted 20 minutes, and then it actually reformed at 3:18 p.m. Storm top divergence was 125 knots at 2:34. So at the same time, this cross section here on the right, we had a storm top divergence of 125 knots. So pretty healthy. CCs, you can see the cross section there in the bottom right, was down as low as 32%. You can see that bullseye there in the cross section. Kind of interesting to note that the CCs, the low CCs, I should say, had a depth of almost 10,000 feet. So that's kind of interesting. Hail spikes, you'd think with a storm that was producing hail this large would be fairly easy to see. But actually, the hail spike didn't even show up until about 12 minutes after we knew about the tennis ball hail falling. The best hail spike I could find was at the 1.3 degree slice. And again, that was 12 minutes after the hail was reported to us. So hail spikes, not helpful at all for giving us a clue that really big hail was falling. ZDR really wasn't a help either. We had both high and low values. When you're looking for big hail, you want low ZDR values if there's no heavy rain mixed in. If you have heavy rain mixed in, you want high values of ZDR. And we had both of those in this storm, as you can see in the upper right panel there at 2:42 p.m. So if you knew where to look, you could find ZDR values that would be correlated with big hail. But if you're using ZDR to determine whether or not big hail was going to be occurring, it was no help at all. CC was very helpful, as you saw in the prior slides, and in this one, where we have an area of 0.9 or less, and I have that circled there. Interesting enough, this also is where we had a beware or a bounded weak ecoregion with that core overhead of Tribune. And again, this image here is taken at 2:42, so this was 2 minutes after we had the hail report come into the office. And looking in the lower right at the 3.1 degree slice, you can see where the top of that beware is. And it's directly overhead at Tribune. And here's a cross section, and that location of the cross section is denoted by the yellow line on the half-degree image there. So you can see the beware compared to what we saw earlier at about 2:34 is much more impressive now, which makes sense given the hail that the storm was producing at this time. The CC cross section, notice the values, the low values, aren't quite as deep as they were at 2:34. Skipping ahead to 2:55 p.m., the storm is now mostly east of Tribune at this time. ZDR continues to be no help as we have a mix of high and low values. I've circled there on the right in the radar imagery where the low CC values are in the white circle there. Uh, what you're seeing is the radar going up from a half degree up to 3.1 and then back down. So about here is where we're starting at half degree and then going up to the 3.1 degree, just to give you an idea of the depth there of the low CC values. And as you can see with the insert there in the lower left, we still have the beware in place. So we have remarkably high values there of DBZ there at the 3.1 degree slice at 2:55 p.m. Here is a cross section. The location of the cross section again denoted by the yellow line. You can see the beware is still pretty intense at 255. The low CC values are starting to get a little bit deeper as well. You can see with the cross section there. Something also to note is we can see the overshooting top there. That's above 40,000 feet at 255 as well. So that's another interesting feature with this storm. Moving ahead to 3:32 p.m. The storm is now south of, not Tribune, but Leota rather, in Wichita County. So the beware is still in place, as you can see with the insert there in the lower left, and it's quite healthy. I think this might have been the most intense that the beware looked in the storm's lifetime, at least over our area. I believe we also received a report of 2-inch hail with this thunderstorm, roughly 9 miles southwest of Leota. So it was still producing severe hail at this time, which makes sense given the presence of a rather remarkable beware and the low CC values that we can see in the half-degree pane there. And here's a cross-section of the CCs. Interesting to see that the area of lowest CCs has actually gone upward in the vertical about 10,000 feet. So to conclude, I have some final comments. As you can see, this storm had just remarkable growth, very explosive growth. Within 20 minutes after forming, we had tennis ball hail being reported. MRMS had absolutely no idea what was going on with this storm. The storm was developing so rapidly, MRMS just couldn't keep up with it. Had 50%, or rather less than 50% probability of severe hail until 12 minutes after we knew about the tennis ball hail in Tribune. There were 3 key features that pointed towards there being severe hail with this thunderstorm. The beware being present, so that immediately lets us know that severe hail is likely with this storm. And then also we had the CCs of less than 0.9 co-located with the beware, which is where we would expect the low CCs to be. We also had storm top divergence well over 100 knots, anywhere from 120 to 140 when the tennis ball hail was reported. The one takeaway with this event was how difficult it can be to visualize or certain features with this storm, such as the beware. It'd be very easy to gloss over that feature when you're simply looking at a plan view and going through the all tilts, as that's not really evident unless you do a cross section. So that's probably the biggest takeaway with this, is having someone, ideally the mesoanalyst, performing cross sections of storms every so often, especially ones that have such explosive growth, as it can be very easy to miss key features such as the beware or low CCs, and kind of tying that to the beware to help you stay aware of what the storm is doing. Well, that's all I have. Thanks for watching. Hopefully some of the material here was beneficial. My goal with this was not to chastise the people on shift who are working this storm, because again, this was a very rapidly intensifying storm. My intent here is just to look at this case and see what we can learn from it so we can be better prepared for storms like this in the future. Thanks for watching and have a great day.